Okay, this is a video to show you an example of how to calculate reacting masses. So the type of question we're looking at here is where it's asking you to calculate the mass of a chemical that you might produce or that might be needed to react with another chemical, and we know how much of the second chemical we've got, and therefore we've got to find the amount of the first chemical. So in this example, we've got calculate the mass of carbon dioxide that you could obtain by adding an excess of hydrochloric acid to 15 grams of calcium carbonate. We've got the equation, so it tells us that calcium carbonate reacts with hydrochloric acid to produce calcium chloride, water and carbon dioxide. Underneath that, they've given us the balanced formula equation. So here we can see we've got 1 mole of calcium carbonate, 2 moles of hydrochloric acid, 1 mole of calcium chloride, 1 mole of water and 1 mole of carbon dioxide. So our first job is to read the question and identify 2 of these chemicals that we're interested in, because we can only deal with 2 chemicals in our working out. So the question says calculate the mass of carbon dioxide. So first one that I'm interested in is finding the mass of the carbon dioxide. So calculate the mass of carbon dioxide you could obtain by adding an excess of hydrochloric acid to 15 grams of calcium carbonate. So I know that I have got 15 grams of calcium carbonate. So therefore, those 2 are the chemicals that I'm interested in. I'm not interested in anything else at this point in the equation. Something to point out just before we move on is this is saying there's an excess of hydrochloric acid. Excess means more than you need. So have a think to yourself, why do we need to have an excess of hydrochloric acid? Just give you a second or 2 to think about that. So the reason we have excess of this is to make sure that all the calcium carbonate is able to react. We want 15 grams to react. We want to know how much it's going to produce. So to make sure the 15 grams react, we add an excess of the acid to make that reaction happen. Okay, so let's go through the steps. So step 1 is kind of done. We've identified the 2 things that we are interested in. Step 2 on the list, so this is going to be step 2 on my list now, is I'm going to work out for the calcium carbonate, because I know how many grams I've got. I'm going to convert the grams into a number of moles. So to do that, I'm going to write down here number of moles of calcium carbonate. Number of moles of calcium carbonate. A number of moles is equal to the mass divided by the mass of 1 mole. Okay. What I'm doing here, just as a reminder, is I'm using a triangle that tells me the number of moles is the mass, and then here mass of 1 mole. So using this triangle, just squeeze it in on the side. Then what I'm doing here is I'm working out, in this example, the number of moles. And if I'm working out the number of moles, I cover that over, and the number of moles is the mass divided by the mass from mole, which is what I've got written here. So now let's put some numbers in. I know the mass from the question is 15 grams. I've got to calculate the mass of 1 mole. So my chemical is calcium carbonate. I'm going to flip to a green pen over. This is going to be my working out over here. So I've got calcium carbonate. And what I now need to do with this calcium carbonate is I need to work out the mass of 1 mole, which is the relative formula mass. And to do that, I need to know the relative atomic masses of the atoms involved and work this out. So 1 times calcium, there's 1 atom of calcium, there is 1 atom of carbon, and there are 3 atoms of oxygen. That means it's 1 times 40, which is 40. 40 is the relative atomic mass for calcium. The relative atomic mass for carbon is 12, so that's 1 times 12, which is 12. And the relative atomic mass of oxygen is 16, so that's 3 times 16, which is 48. So I've worked that bit out. I add all these up, I now get an answer of 100. So what I can now do is go back to where I was in the original calculation, and I know now the mass of 1 mole is 15 divided by 100, which is going to be 0.155 moles. So the first step in the calculation is done. I've calculated the number of moles that's in 15 grams of calcium carbonate. My next step, so it's step 3, and here, what I'm going to look at from here is the ratio from the equation. So this is the ratio from the equation. If I go to the equation, and I'm only interested in, remember, the two chemicals that are highlighted here and here, I can see that there's no number in the equation, the balanced equation in front of this. So there's 1 mole of calcium carbonate, and there is no number in front of the carbon dioxide. So there's 1 mole of carbon dioxide. So down here, I can say that 1 mole of calcium carbonate forms 1 mole of CO2. 1 mole of calcium carbonate forms 1 mole of CO2. From what I've done here, I've only got 0.5 moles of calcium carbonate, so this is actually now 0.15 moles of calcium carbonate. And because it's a 1-to-1 ratio, that's going to be exactly the same number of moles of CO2. So it's a 1-to-1 ratio, so the moles are the same. If it'd been involving the hydrochloric acid, then you can see here this is a ratio of 2, so I'd have to think about a 2, and that would mean if this was 1 to 2, so it's 1 mole making 2 moles, I then have to double this, so it's 0.15 would become double that, so it's 0.3 moles, and that's how you use the ratio in your example. And if I get a chance, I'll put one of those in later on to show you one with a ratio in. Okay, final steps. Step 4, so what I now know is I've got 0.15 moles of carbon dioxide, and what I need to do now is convert that into a mass, grams, of carbon dioxide, so I can tell them how many grams I'm going to produce. So using the triangle, I cover mass over, and mass is going to equal number of moles times the mass of 1 mole. So I come back down here, and my final step is to say the mass of carbon dioxide is equal to the number of moles times by mass of 1 mole. So number of moles is the 0.15 that I calculated in my previous step. Mass of 1 mole, I've got to do the same thing again. So over here, let's go back to green. I should have done it in green, we'll go back to green. There is 1 carbon and 2 oxygens. So that's 1 times 12 is 12, 2 times 16 is 32. Add them together is 44. So the mass of 1 mole of carbon dioxide is 44. You work those out, and I did it earlier on my calculator, and it is 6.6 grams. Okay, 6.6 grams. So if I go back up to here, this means if I started off with 15 grams of this, I should make, if everything works to plan, 6.6 grams of carbon dioxide. Remember, don't fall into any traps. If this was 15 tons, this would be 6.6 tons. If it was 15 kilograms, this would be 6.6 kilograms. The units don't matter as long as they're the same each side. The ratio in that reaction will be the same. Okay? Hope it helps. Best way to do this now is to practice some of these yourself. Watch the video a few times, get used to the routine. It's the same routine. Those 4 steps: identify, number of moles, ratio, and then the mass. Practice it, have a go yourself, get confident, and come back to the video if you need further help to watch this. Okay?